And the stream is started. Maybe I'm over-modulated this microphone. I think it's okay. So, kind of choked up this morning. I probably will be clearing my throat a lot. I apologize in advance. Maybe it's the change of seasons. I think it's even been a little bit smoky here in California, or something's going on. But anyway, good morning. Welcome back to the channel. Welcome if you are new. Going to do some science today. I like doing science. The last couple of videos about Hurricane Helene and the impacts and where Hurricane Helene really came from and how it became what it became. That was all sort of sciencey stuff, right? And even when I was coming down hard on the hillbillies in the comments section, bitching and moaning about, how ill-treated they are. That wasn't science as such, but that was me trying to do a kind of a cross-section psychological profile on who these people are and what they're up against. I don't know how well that worked for you. I think it's fascinating how people behave. And I think our future as a species is going to depend on exactly how people behave. Okay, completely and totally on how people behave. We have a lot of work to do, people, and I'm going to need my glasses. So, Milankovitch cycles. Milankovitch, he was a dude, way back when, didn't have a digital computer, and yet he was able to calculate that that the Earth's orbit was not we knew that the Earth's orbit around the sun was not a perfect circle. We knew it was elliptic. We knew that the Earth on its axis, the tilt, the North Pole and the South Pole, the tilt, wasn't zero. There is a tilt, and we also knew that the tilt varied a little bit. And there was some other orbital things going on, and so he just got really curious about, what the sum total of all those orbital mechanics would be. I need to say right up front that the calculations are extremely complicated to do by hand. A lot of calculus, I would guess, but are very easy to do with digital computers. So he was doing this back in the day when you basically had to do it, doing something like a Fourier transformation with just paper and pencil and a chalkboard or something like that, right? Maybe he had a slide rule or a circular slide rule. I don't know what he had, but he didn't have much. And so he made these calculations. And since then, of course, really any high school class with a personal computer or laptop computer can calculate the Milankovitch cycles as far back as they want to go in just a few seconds. But his accomplishment back then was pretty exciting. A real testament to the human mind and human will to just figure things out, right? People for a long time, certainly since, it goes back even to the Greeks. I mean, come on, let's give the devil his due here, okay? The Greeks knew that the earth was round and they knew its circumference. People have been looking at the earth as a system and as an object in space, and knowing it was an object in space. And we've been doing this for thousands of years. We had this interlude during kind of the medieval times after the fall of Rome up to about the Renaissance. There was maybe a 1,000-year period in there when we just totally dropped the ball and had witch hunts and burned people at the stake and had religious wars and argued about how many angels can dance on the head of a pin. And we sort of lost our minds for a while there for about 1,000 years. But since about the time of, Newton and Benjamin Franklin and a bunch of other thinkers, people who liked to measure shit and just understand how the world really works, we've been doing pretty good, right? And so this Milankovitch fellow comes along and he's looking at the orbital mechanics of the Earth, and he made some calculations. He figured some things out. It turned out to be really amazing. And now we have the Milankovitch cycles. So what role does the Milankovitch cycles play in climate change? Well, if you've been in this space for very long, watching, all the science unroll and all the arguments and of course, watching the weather and the extremities to which the weather can get, then you've probably at least heard about the Milankovitch cycles. And change screen, go here. What is wrong with this? What is it doing? I gotta find. Oh no, did I lose it? No, I didn't. See, this is the thing. I got to find now. Why isn't it? Oh, there it is. Sorry. It's early in the morning, and I haven't even had more than 2 sips of coffee, so you're just going to have to put up with me. It's not that early. Come on, it's 9:45. What's wrong with you? So, here's the Milankovitch cycles. Now, actually, this chart has 2 things on it. The black line is the calculated Milankovitch cycles. And the Milankovitch cycles are a calculation. So the black line on this chart is smooth. This is what a computer will give you. It does all of the Fourier transforms, and it does all the calculus and the matrix algebra, whatever else they're doing here, right? And it plots a black line. And these are the Milankovitch cycles. And what the unit on the cycle is solar irradiance. And I think at this point, it's pegged to 65 degrees north in the month of July. So dead of summer in the northern hemisphere at 65 degrees north, which is pretty high up. 90 degrees is the North Pole and 0 degrees is the equator. So this is well past middle of the journey from the equator to the North Pole. I think right here where I am in San Jose, it's like 35 degrees north. So 65 degrees north from where I am. We'll be up in Canada somewhere. But the reason they calculated the Milankovitch cycles at 65 degrees north is because they have temperature-derived data from an ice core taken in Vostok, Russia, at 65 degrees north. So they did the thing. They have the ice core data, which shows temperature. Not because of the temperature of the ice. They're looking at oxygen isotopes and things like that trapped in the ice. And from that, they can these can be used as what they call a proxy to give a very fair estimate of the temperature at which that ice was formed. So the pink line is the temperature data derived from the isotope contents of the ice core lifted from the Vostok bore, okay, at 65 north. So the pink line is temperature, and the black line is the Milankovitch cycle, which is a calculation. It always is. The Milankovitch cycle is always a calculation based on orbital mechanics, which Newton taught us how to calculate orbital mechanics, and he invented calculus for the purpose of doing that. So we're using tools from the times of Sir Isaac Newton, and we get a line. You can derive this, as I said, using a computer. You could do it. The computational power in your cell phone is more than adequate to do this. So the black line is the Milankovitch cycle. Again, the unit of measure in the Milankovitch cycle is solar irradiance. Solar irradiance. So solar is sun, and irradiance is light coming from, basically. So at 65 degrees north latitude, that's a spot on the Earth. It's not the equator, it's not the North Pole. It's a spot on the Earth somewhere between the two. And at that spot, you can calculate the solar irradiance due to the influence of the Milankovitch cycle. Did you get all that? And again, the calculation is trivial. At 65 north latitude, they calculated the expected solar irradiance, the amount of light that would impinge upon that exact spot, based upon the influence, the known calculatable influence of the Milankovitch cycle. Now, I'm talking about the Milankovitch cycle. Actually, I want to let you know that I was turned on to this topic today. It's just a random thing I ran into. How the Milankovitch orbital variations shape the Earth's climate. This is not a bad video. And if you've had any questions or concerns or confusion about what the Milankovitch cycle is, you can watch this video. The Milankovitch cycle is actually extremely simple. It is not an external influence. It is not changes in the sun's output. It's not changes in intergalactic cosmic rays. It's not changes in anything having to do with anything in the cosmos. Not even the proximity of the planets to each other. It is simply how our Earth behaves as it wobbles and tilts and orbits around the sun. It's just a calculation. It's done with calculus. It can be done on a cell phone. The computational power in your cell phone can do this calculation easily. So the orbital mechanics of the Milankovitch cycle have always been there since the formation of the Earth. Probably a lot of what we measure in the Milankovitch cycles, all the different things that have to be combined into the one line, all those were probably created by the Theia impactor that hit the Earth about, I don't know, I want to say 1 billion, maybe half a billion years into the Earth's own formation. No life on the Earth. It was just a big ball of magma being constantly bombarded by planetesimals from the rest of the solar system. This was called the heavy bombardment period in the Earth's evolution. The Earth's evolution as a piece of rock. Okay, there was not even any liquid water. It was too hot for that. In fact, there's a lot of question, where the hell did the water even come from? But in any case, when the Earth as a rock was still evolving and forming into the planet we know and rely on today, it got hit by a big thing, a planetesimal or a planetoid, a small planet called Theia. And Theia hit the Earth, and I saw some dispute of this recently, but I don't know. I think the evidence is pretty good that Theia, the impact of Theia with the Earth, created the moon. It basically blew a chunk off of the Earth as a cloud, or maybe even think of it as a ring around the Earth that then coalesced under its own gravity into the moon. The moon is made out of the Earth because the Earth got whacked by a big sledgehammer called Theia. And most of Theia actually went into the Earth. Theia did not spin off of the collision and become the moon and then orbit the Earth. The moon is made from the Earth, and it orbits the Earth because it shares the Earth's angular momentum. This is all physics. Theia hit the Earth, had its own angular momentum, and that got absorbed into the Earth-Moon system. And Theia is now inside the Earth. And when they do essentially X-rays of the Earth using earthquake data, they kind of see these big blobs interior to the Earth. And, as far as I'm concerned, that's Theia. I don't see any reason why it wouldn't be. Theia hit the Earth and just became absorbed into the Earth. And the Earth became both bigger because it just accumulated some mass from outside of itself, and then it became smaller because it spun off the moon. But the moon stayed with the Earth because the Earth and the moon system, the two of them together, have to conserve angular momentum. Wow, did I just say all that? We've always had the Milankovitch cycles, since Theia, at least. The Earth's eccentricity around the sun, the Earth's tilt on its axis, the wobble of the tilt, all the other wobbles built into the system. It's like what happens when two cars hit each other. They were going this way and they were going that way, and then they hit each other, and then they kind of go around each other, and they flip over the side of the road, and one goes over this way and one goes over the other way. And somehow all the angular momentum and all the velocities, vectors are all combined and conserved, and and you get something different from what you started with. So the Earth's orbital mechanics are based probably largely upon the Theia impact when the Earth was still just a hot rock. Oh, and as a bonus, we got the moon. So that's double plus good. Now, it bears saying that the Milankovitch cycles of the Earth, which are just the Earth and the sun, with the moon maybe adding a little bit, do contribute to the Earth's global climate. The Milankovitch cycles don't contribute to any of the weather, which is kind of a daily phenomenon, right? But the cycles of the climate, which do drive the weather, are influenced by the Milankovitch cycles, because the Milankovitch cycles influence what we call insolation. I'm going to go back to this thing here. The Milankovitch cycles, because the Earth got whacked, so now things aren't flat and straight anymore. Now they're all complicated and messy because we got into a car wreck, and now we're all sad. Okay, the Milankovitch cycles, as you see from the black line, influences insolation, and all the energy that drives the biosphere, the part we care about, and the cryosphere, that's the ice, right? And the hydrosphere, I mean, that's the rain. So the hydrosphere, the cryosphere, and the biosphere are driven by insolation. Insolation. How much light or how much heat from the sun in the form of light are you getting at the surface? So the Milankovitch cycles, and well, let me describe this chart a little bit. The bottom axis goes from 0 on the right, so things are a bit backwards if you're familiar with chartology. 0 is on the right, years relative to present. So 0 is now. 0 years relative to present is now. And then all the other numbers are negative numbers compared to now. So you can think of these as time before now, and they're years. So there's a major tick mark at minus 50,000 years. So that's 50,000 years ago. Then there's another major tick mark at 100,000 years. Negative 100,000 years. That's 100,000 years ago. Then there's another one out here at about 200,000 years. And that's when about the time when humans, modern humans, Homo sapiens, showed up on the scene. I've also heard 300,000 years, but yeah, a while back, right? 300,000 years is actually off the chart on the left. But during the time period encapsulated in this chart, which goes back 250,000 years, we've had, let's count them, 1, 2, 3, 4, 5, 6, 7, 8, 9 and a half, 10 Milankovitch cycles. It's really 11. I'll count them again from the left because this little blip that's kind of isn't its full cycle. It probably still counts. And you'll notice how periodic they are. Have you noticed that? That they're kind of evenly spaced. And this was the existence of the Milankovitch cycles was signaled to us that there was something going on by the periodicity of the ice ages, the glacial periods during the ice age. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is kind of funky. 11. We are, and the peaks of these 11 maxima of solar irradiance, these are all called interglacials, or between the glaciers. And you'll notice from the ice core data, which follows in the pink, that the warmest temperatures, how are the temperatures done? See, there's a 0 line on temperature, which I guess is modern times. And all the others are either above modern times, like 3 degrees above, or below, cooler than modern times, down to minus 9 degrees cooler than modern times. This is all degree C, by the way. So you'll notice the pink line goes up and down and up and down and up and down in a periodic fashion. And surprise, surprise, it follows the Milankovitch cycles. So, correlation isn't always causation in science, but hey, in this case, it could easily be, because we know that the presence or absence of large quantities of ice during glacial extremes or glacial minima are possibly going to be covered, explained by temperature. Why not? Ice melts when it's warm, and ice advances when it's cold. So if it's entirely possible that the temperature may be driving the ice. And where do we get our temperatures? From solar irradiance. Now, the temperature of the Earth is actually very complicated. It has to be said right away, that the temperature of the Earth, as it is so constituted today, would be 60 degrees Fahrenheit, 30 degrees C, colder than it is in modern times, were it not for the greenhouse effect. The greenhouse effect, of course, is greenhouse gases, so-called, because they cause the greenhouse effect. Greenhouse gases such as methane, carbon dioxide, nitrous oxides, water vapor in the atmosphere that trap heat. Where's the heat coming from? The sun. It's not even coming from the sun as heat. We only really get light from the sun. But the light, when it strikes the Earth, is absorbed, and conservation of energy, it doesn't just go away. Even if it hits a very dark object, you think, well, that's a dark object, I guess the light went away. No, the light doesn't go away. It gets transformed into heat. A summer day, the asphalt is 200 degrees out there, right? So the insolation at a peak Milankovitch cycle will warm the Earth, and that will melt the ice. And then you'll have an interglacial where the ice retreats and there's more land than there is ice. And then eventually the Milankovitch cycle swings the other way, and that reduces solar irradiance and therefore cools the planet. It's the greenhouse gases that are trapping the heat at all. So this is very complicated. The temperature of the planet is actually really complicated. It's not as simple as saying, oh, a peak solar irradiance during a maximum Milankovitch cycle, that's always going to melt the ice, and that's always going to give you an interglacial. It doesn't have to be that way, because it also depends on how effective the greenhouse effect is. And so when you look at this pink line, and it's going up and it's going down, sure, it follows the Milankovitch cycles. It kind of would have to. Because the temperature of the Earth is dependent on solar irradiance to a large degree. But the temperature of the Earth is also dependent on how much ice there is. And the temperature of the Earth is also dependent on how many greenhouse gases there are in the atmosphere. And how much water vapor there is in the atmosphere. And then the amount of water vapor there is in the atmosphere depends on how much ice there is on the planet and where the ice is. And is the ice over water? Because that'll decrease humidity and decrease evaporation and so on and so forth. So it's really complicated. This pink line is super, 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 super complicated. But it goes up and it goes down. And when it goes up, it doesn't stay up very long. Most of these interglacials are fairly short. Some of them are like one data point before they start going back down again. Except when you get close to 0 years. And I want to draw your attention to what's happening on the far right of this chart, because this is absolutely critical. Back in the 70s, there was articles coming out in newspapers about how, oh, yeah, we could be going into another ice age. That's what they called it. This whole chart is the ice age. This whole chart is Earth dominated by ice, because it really was, and kind of still is. Ice and cold temperatures that result from the ice. The ice age is itself variously figured to be either 3 million or 5 million years old, and that the Earth began cooling toward the current ice age about 20 million years ago. So this has been a long-term phenomenon having nothing to do with the Milankovitch cycles. The Milankovitch cycles are 50,000 year, 100,000 year cycles that overlap in various and interesting ways. But the ice age began 20 million years ago and probably got serious about 5 million years ago. And then we have these interglacials. The Milankovitch cycle was always there. It's not like it started 5 million years ago. Oh, Milankovitch cycles, that started 5 million years ago, and that's what's driving our climate. No, it isn't. The Milankovitch cycles have been there exactly as they are now since the Theia impact. What, 4.5 billion years ago? The Milankovitch cycles were always there. This is the orbital mechanics. Do you think the Earth in its orbit is changing? How exactly is that happening? How exactly? Now, the sun's solar output has changed, again, over hundreds, even hundreds of millions and billions of years. And we can calculate that, and we can kind of know how the sun actually behaves internally with its own nuclear forces. And so we kind of know what's happening with the sun's solar output. But it's not this. It's not this black line. It's not this pink line. That's not solar output changing. The solar output on this chart would be a flat line. They don't even put it on here because it's not interesting. The interesting part is what's happening with Earth orbital mechanics, which are summarized effectively through use of the Milankovitch cycles. In this case, at 65 degrees north latitude. Over here on the far right of this thing, you're going to notice something. Even though in the 70s they were able to predict, oh yeah, we should be going into another glacial epoch here anytime now, because the Milankovitch cycle is really on the descending phase. And according to this particular drawing at 65 degrees north latitude, we should be well on our way to the next glacial maximum. But we're not. And look at what the pink line is doing. It's going down a little bit, but not like it should be. It's pretty much almost flat. And why is that? And I've never heard anyone answer the question of why is that pink line not going down? The Milankovitch cycle is going down. It's going down like a rocket. And remember, this is calculations. This is stuff you can do in a spreadsheet. And so we should be heading into the next ice maxima. The glaciers should be growing. The ice on Greenland should be getting thicker. The amount of ice at the North Pole should be getting more abundant and thicker and spreading south into the Bering Straits and into, off of Norway and eventually, completely icebound Newfoundland and really the U.S. Northeast, right? Maine and the New England states should be completely bound in ice by now, because the glaciers and the ice fields and ice shields should be moving. But they're not. We're not going into another glacial maximum. Even though the Milankovitch cycle says, oh yeah, time to freeze, we're not. The pink line isn't going down much, going down a little. And I actually have a theory. Yeah, it's not a theory, it's a hypothesis, okay? Well, it could almost be a theory. I could probably, if I wanted to spend the time, I could probably work up a theory on how this is actually working. I think humans have been changing the planet. We had a really good interglacial. We haven't had as good an interglacial as we had maybe 125,000 years ago. That was a pretty good one. Although it was short notice, it was a good warm period. It was even warmer than it has been today, but it was short. And even though there were humans on Earth and we probably had domesticated fire and we had language and we had stone tools and we had everything that we started this particular interglacial with. What were we, 120,000 years ago? 20,000 years ago, we entered a really nice interglacial, plenty warm, but we did the same thing 125,000 years ago. So what's the difference between then and now? I think the difference between then and now is that, we got our act together this time. We had enough innovation in the last 125,000 years that when we finally entered a Milankovitch cycle that gave us a really robust interglacial period of ice minimum, we took advantage of it. We went nuts, and we began clearing forests, and we began draining swamps and desertifying areas, and we started burning things, burning forests, and putting carbon into the atmosphere. And as we injected carbon into the atmosphere, remember, the temperature of the Earth is complicated. It's not just, the Milankovitch cycles. No, it's not. It's also dependent on the greenhouse effect. It's also dependent on how much ice there is. It's dependent on how much of the land has trees versus desert. The temperature of the Earth is really, really complicated. In fact, you can even say that the temperature of the Earth is chaotic. There are so many moving parts, and trying to calculate the temperature of the Earth, that I don't think anyone's ever done it or even tried. It's just too complicated. You can observe it. Instrumentation, we can observe it, but we can't really understand it. And so when you see this chart where at year 0, there's been this long interglacial period, and it's been really stable, even though the Milankovitch cycle should be dragging us screaming into the next glacial maximum. And the temperature, by just looking at the black line, the temperature ought to be, minus 3 degrees C from what it was during modern times. It's actually increasing. We're talking right now at the IPCC level that we have to keep the Earth's temperature from going above 1.5 above zero or 2.0 above zero. And this chart shows 3.0 above zero. And guess what? There's now research coming out of groups run by James Hansen that said we're probably going straight to 5 degrees C above zero. That's even above this chart. That number wouldn't even fit on this chart. We're going to go above 5 degrees C. I think it was actually 4.7. That's almost guaranteed. And then if we hit 4.7 or 5, data gathered from the PETM, Paleo-Eocene Thermal Maximum, suggests that once you hit 5, other weird things start to happen. Air quotes, trademark, registered. Okay. And then you go straight to 10. 10, again, wouldn't even fit on this chart. The minus side only goes to -9, and we'd have to double the size of this chart to contain where we are going. And how is that happening? It's not because we changed the Milankovitch cycle. The Milankovitch cycle is already turned over. We should be going into a glacial period. We're not. We're having the longest and most stable interglacial humans have probably ever seen. And why is that? It's not because we changed the Milankovitch cycles. We didn't. We couldn't. The last time the Milankovitch cycles were changed was when Earth was hit by a planetoid and the moon was created. That's the last time the Earth's orbital dynamics was impacted. That was 4.5 billion years ago. So now, what's happening? Well, of course, it's the greenhouse effect. And we're modifying the greenhouse effect because that also helps determine the temperature of the Earth. Not just the Milankovitch cycles. The Milankovitch cycles help influence the temperature of the Earth in the absence of anything else. But we are not just anything else. We're humans. And we can change the atmosphere. And we have. We know that because we can measure it. During all of these interglacial periods, the CO2 level in the atmosphere never got above 250, 280 parts per million. We're now at close to 450 parts per million. And if you consider all the greenhouse gases, we're at 500. And we're not even talking about stopping burning fossil fuels. Well, what's the number again? I told you there'd be a quiz, didn't I? I told you there'd be a quiz. Okay, here, quiz time. Quiz time. How many barrels of oil per day, crude oil per day, are pulled from the Earth every single day? How many barrels of oil are extracted from the Earth every day? You remember the number? I said you wouldn't. I said you wouldn't remember because it's too big a number. It's too complicated a number. There's no place in your brain for this number. I remember this number because it's fucking scary. You're not nearly scared enough to remember this number. The answer is 400 million barrels of crude oil a day are extracted from the Earth every single day. I'm sorry, it's not 400. 100. See, I'm thinking too far ahead. 100 million barrels of oil a day are extracted from the Earth reservoirs and burned because we have nowhere to store 100 million barrels of oil a day. We have nowhere to store that. We just set it on fire. And we do that by refining it into gasoline and diesel and kerosene and jet fuel and all the other derivatives. And we use the derivatives to make plastic and asphalt and useful things, right? Pharmaceuticals, fertilizers, pesticides, paints, everything else. We use them for manufacturing. And then, of course, we use for transportation of all kinds, jets, cargo vessels, trucks, cars, trains, all the gasoline, diesel, jet fuel, and kerosene. Those are used for transportation. And so we burn it all every day. And every day we need it. Every day. We have to start every day. Okay, here we go again, folks. Get out there in the oil fields, and I need you to produce, let's see, what's the number again? Oh, yeah, 100 million barrels of oil today. And tomorrow, we're going to be right back out there producing yet again another 100 million barrels of oil a day. Every day. Because we need that. Every day. 100 million barrels of oil. Now, that was the number I just got confused. Again, it's early. I'm sleepy. Coffee. I'm 65. My brain doesn't even wake up until I've had 2 cups of coffee. After we burn 100 million barrels of oil every single day, and a barrel is 40 gallons. After we burn or use or do something with 100 million barrels of oil a day, then on an accumulated basis, we release into the atmosphere annually 400 billion tons of CO2, which is a greenhouse gas. We extract 100 million barrels of oil daily. Mostly we burn it to do cool things, and we love our modern life. And that means that on an annual basis, 40 billion tons of carbon dioxide gas accumulate in the atmosphere. And that's where it stays. Some of it transfers to the ocean, and some of it is used for weathering rocks, and some of it, that's about it. The ocean, some of it transfers to the ocean, and some of it is used to break down rocks. And the rest of it is just either in the atmosphere or the biosphere. And the movement between the atmosphere and the biosphere and back of the atmosphere, back to the biosphere, that's called the carbon cycle. And the carbon cycle is a cycle. It goes around and around and around. And so, whereas a given CO2 molecule. It might be in the air, it might be in a plant, it might be in an animal, it might be back in the air. It's always between the two. And if your biosphere is expanding, if your forests are growing and your animals are becoming more abundant, well, then you'll pull some of the CO2 out of the atmosphere into the biosphere. If your biosphere is shrinking, like it is, right? Animals are going extinct. We're killing all the plants and the trees. We're setting fire to the forests. We're digging up trees and setting fire to them and planting row crops or planting something that doesn't quite count the same as a tree does. Then the amount of CO2 in the atmosphere is increasing because it has to be in one or the other. And some of it gets absorbed into the oceans, where it has a whole nother bunch of problems, right? So the CO2, once it's in the atmosphere, it can move into the biosphere, but then it really has to move back eventually, because it's just a cycle between the two. So as we have been modifying the Earth, which we have been doing, and you can just look at this chart right here, climate data information. Look at that pink line. We've been modifying the planet since, I don't know, what is that, 10, 20,000 years ago? Yeah, that sounds about right. We've been doing this. We've been doing a pretty good job. And you can't even see it on this chart because the data isn't there. But there's a pink line that goes straight up from where it is now. It's been going, the average of the little wiggles at the far right of this chart, they're kind of tending down, but you'll notice they're not tending down like anywhere else on this chart. They're not falling off a cliff like they should be. They're tending downward, fair enough. But then, just not even on this chart, it jumps up suddenly to 1.5, which is halfway between 0 and 3. So somewhere in here, there should be a pink line that goes straight up, but you can't see it because it's off the edge of the right side of the chart. They could have put it on here if they wanted to, but they didn't. It'd just be one line. It would go straight up to 1.5 because that's where we are right now. Right now, we are at a little below, a little above 1.5 degrees C above baseline, which is, in this case, is 0. Actually, compared to pre-industrial, it might even be closer to 3. We might even be closer to 3 compared to where this chart was made. I'd want to see that. I'd want to see where we are right now. It's too bad they didn't put it in here, the most recent data on the temperature of the Earth. They could have, because we have it, but they didn't. So that's kind of unfortunate, because I would like to have seen it, because right now, based on where they put 0, I'm not sure where we would be on this chart. We might be actually closer to 3. Yeah. So that's the Milankovitch cycle and its influence on the temperature of the Earth, except recently, like the last 20,000 years. And that's data you have to know. You have to know that. Because people are going to come at you and they're going to say, climate on the Earth is determined by the Milankovitch cycles. Okay, fair enough. But the temperature of the Earth, this isn't climate, by the way. This is the Milankovitch cycles and temperature, which is not climate. It's just temperature. Climate is a sum total of your temperatures, your rainfall, your whatever else, right? This is just temperature, which is all they could really get from the Vostok ice core is temperature proxies. And so people will tell you, the Milankovitch cycles. You think you understand something about climate change. Well, according to the Milankovitch cycles, if you ignore the last 20,000 years, according to the Milankovitch cycles, which is just math, Earth mechanics, it's just mathematics. You can do it in a spreadsheet. Our climate is driven by the Milankovitch cycles. And, up until 20,000 years ago, that was largely true. I mean, here it is. Here's the picture. Wow. There you go. Sure enough. Good on you. Yeah, you're probably right. I mean, there are some departures, right? Clearly. But like I said, temperature is complicated. Yeah. So it doesn't follow 100%. It's not an absolute correlation. It's a influence, like I've been saying. The Milankovitch cycle, the Milankovitch, you try saying it. The Milankovitch cycle is an influence on the temperature and therefore the global climate. It's an influence. It's not a perfect correlation. And in the last 20,000 years, right, on the far right of this figure, look at what's been going on. What's that about, I wonder? Well, that's interesting. So much for your contention that the Milankovitch drives the climate, because what kind of shit is that? Wow, we should be well on our way to the next ice maximum. We should be under miles of ice by now, and we're not. I mean, that's a good thing. That's a good thing. And here's why I have to say a couple of things about the Milankovitch cycles. The Milankovitch cycles are probably really, really bad for civilization. I'm just going to put that out there. We haven't had civilizations probably. I mean, modern humans have been around for 300,000 years. Where's our modern civilization? What took so long? Why now and not any of these other times? Especially not. I mean, we could have done this 125,000 years ago. We had a nice interglacial. Nice. That's a nice interglacial. But look what happened. Right after 125,000 years ago, it did a major dive. It got cold. And that's why you couldn't have civilization. We might have had something, by the way. That's fun to speculate on, isn't it? 125,000 years ago, that was a long time. Modern humans, anatomically and socially, modern humans, 125,000 years ago, they had a nice interglacial. That was nice. Look at that. That was nice. Look at that insolation. Look at that maximum in the Milankovitch cycle 125,000 years ago. Very sweet. So what happened? We didn't get it together. What happened? I don't know. I actually don't know. We could have done it. That was the time. Why now and not then? Did we just not have had we not domesticated dogs yet? I mean, could be, right? Maybe dogs helped us create civilization. Maybe something else about domestication of animals. Maybe we hadn't domesticated enough animals or plants to do the thing that we did during this interglacial. You know what the thing was? We settled down. We created modern agriculture, fields tilled with plows and oxen pulling the plow and organizing humans into villages and then towns and cities and having rulers and religion and predictability and walls and protection and we even had time to have kings and emperors and people wore silks and we did. Maybe it was because sometime between 125,000 years ago and 20,000 years ago, we did the trick. We domesticated plants and animals sometime during that time. And that was the tool. Boom! It was there. And then this great interglacial. Well, it's not that great. Look at that Milankovitch cycle. It's putsy. It gets up to 470, watts per square meter. It gets up to 470. I can't tell if that's 470. That can't be right. 470. I can't read this chart properly. I could read the description, but is it 470? Yeah, it was 470 watts per square meter. Okay, my glasses aren't good enough. I can't tell if there's a decimal point in there. But anyway, yes, 470 parts per million. I've got CO2 on the brain. More coffee. 470 watts per square meter. So that's kind of putsy. 470 watts per square meter. The Milankovitch cycle maximum 125,000 years ago, that was more like 490 watts per square meter. And look how warm it got. That was nice. That was tasty. Yeah, we should have modern civilization. We should have had the big thing happen back then. We were completely anatomically and culturally modern humans. What was the difference between then and now? Now being 20,000 years ago. 20,000 years ago, maybe we just had more tools. We had domesticated fire, which they did have 125,000 years ago. I think it's now thought that Neanderthals domesticated fire, meaning they could make their own fire on demand. But 120,000 years ago, modern humans, maybe we had domesticated dogs and they were useful for hunting. But did we have anything else? Did we have cereal crops? Did we have ways of tilling the soil? Maybe we didn't. So when we had this great interglacial period, we just didn't have the tools to do the thing. But 20,000 years ago, oh yeah, we were ready. We were ready, And even though it was kind of a putsy interglacial, only got up to 470 watts per square meter, man, that was good. Is that all we're going to get? Good enough. We're going to do this. Let's do it. You ready to do this? Let's do this. Let's go. And we did it. And we created settlements and cities and religions and domesticated crops, and we expanded out of Mesopotamia, and we took over the entire fucking planet. And we stopped the glacial advances. We just stopped it. We stopped it. That was one of the three things I wanted to say. And I took a long time saying it. And I almost didn't get to the other two, but now I'm going to. Something happened 20,000 years ago that made us and our relationship to the earth different. I think it was our readiness, because we had the right tools in our toolbox to settle down and basically take over the earth. We'd had enough time as modern humans to be able to suddenly to do that when the conditions were right. And 20,000 years ago, the conditions were right. And then we started setting fire to everything. And, and that's why we're not going into the next glacial epoch. We're not doing it. We should be. We understand the Milankovitch cycles. It's a calculation. And we should be going into another glacial maximum. But we're not. And that's good. That's not a bad thing. I'll take that. I'll take that. Sure, why not? I'll take that. We're modifying the earth, whether we intended to or not. We did. We modified the earth so that the earth cannot plunge into another glacial maximum. And it isn't. In fact, if anything, it's plunging the other direction. And that's critical to know. When they come out and they tell you, well, global climate, it is to laugh. It's all about the Milankovitch cycles, and I know you don't know what that means, and I'm not going to explain it. And just take my word for it. This is all about the Milankovitch cycles, and soon you'll see it'll start to freeze again, and one day we'll go back into an ice age, and you'll be laughing about global heating. No, we should be going into an ice age as of 10,000 years ago. Oh, we didn't. How come? Because humans, we did something. We set everything on fire. We increased the CO2 in the atmosphere from 250 parts per million to the current 420 something. And it's going to 500, and it'll probably go to 1,000. And what are you talking about? You can't have ice on a planet with 1,000 parts per million of CO2 in the atmosphere. You can't. You'd like to, but you can't. So there you go. So is burning fossil fuels a problem? I mean, look, we could have done this differently. Maybe we already knew about the Milankovitch cycles. Maybe 125,000 years ago, we had a great shot at creating civilization during the last really, really good interglacial, 125,000 years ago. And we figured out the Milankovitch cycles, but then it just started getting cold too fast, and we lost our civilization. But let's say we remembered the Milankovitch cycles. Then we could calculate the Milankovitch cycles, and we could come along and we could say, okay, watch this. We're about to go to 470 parts per million, according to the 70 parts per million. 470 watts per square meter of insolation. That's when we need to do this. Okay, what should we do? What should we do? We don't want the planet to freeze again. We had a great shot at a historic human civilization 125,000 years ago, but then the planet froze and buried all of our cities under ice. That sucked. Let's not let that happen again. Okay, what should we do? Well, we need to increase the CO2 in the atmosphere somehow. Oh, that's stupid. We can't do that. Conservation of matter. What are you talking about? I know, but listen to me. There's all this carbon that's been buried in the soil, in the rock, right? We call it coal and crude oil and natural gas. It's all been buried. But if we could get that carbon out of the ground and into the atmosphere, then that would help to warm the planet, and we wouldn't have to worry about another glacial maximum. It wouldn't get cold. It would just stay warm. And if we could do that, if we could figure out how to do that, well, what are you talking about? The coal, it's under the ground, and the oil, there are some places where it oozes to the surface, and we could do something with that, but its reservoirs are thousands of feet below the surface. And what are you proposing? Well, here's what I propose. We dig tunnels, and we dig into the ground, and we find the coal, and it's just a rock. We can just dig it out of the ground like we do gold and silver and copper, right? So we just dig the coal out of the ground, and get this. this is the genius part, right? We've already domesticated fire. And we've got this coal that we just dig out of the ground with shovels. And we bring it to the surface, and we take the fire, and we set the coal on fire because it will burn. And then, when it burns, it releases the captured CO2 that the plants captured and made the coal. It burns, it releases it into the atmosphere. And if we take all the coal out of the ground, and we bring it to the surface, and we set it on fire, and we let it burn, it'll increase the CO2 in the atmosphere. And then they'll be stroking their chins saying, wow, really? Well, I guess we could do that. We have the fire. We know where the coal is. We could just dig it out of the ground, set it on fire, and the CO2 will go in the atmosphere. Well, it's physically possible. I mean, is it worth doing? Can we move enough coal? Well, yeah, look, I did a quick calculation. We just need some people who are dedicated to doing this, and they have to work for a certain number of centuries. Sounds like a long time, but look, we're trying to fight ice. We're trying to fight the next glacial maximum. We don't want a mile of ice over New York City, or whatever they're calling it at the time. We want to fight this. We want to stop this. We want to stop the ice from advancing. So if we just dedicate ourselves to pulling all the coal out of the ground, bring it to the surface, and using fire, which we have plenty of, to set the coal on fire, let the CO2 go in the atmosphere, increase the CO2 amount in the atmosphere to some critical value, whatever it is, maybe it's 450 parts per million, and then we can stop the ice advances by enhancing the greenhouse effect and warming the planet. And then they all sit back and they're like, damn, I think he's right. Or maybe she. That would be a woman, right? Damn, I think she's right. Could we do that? Man, how much coal is that? Well, it's this many tons, and we have to burn it, and it's a certain rate of extraction. Yeah, okay, that's like thousands of people, but hey, we're trying to fight the ice ages, right? And so all we have to do is burn the coal. It's not even valuable. It's just a stupid black rock. Yeah, but listen, there's more. There's this natural gas. We could let that out of the ground. And you don't even have to burn the natural gas. Just let it out of the ground. Find some way to poke holes in the surface of the earth where the natural gas is and just let it vent into the atmosphere, because that's methane. And that shit is 80 times more potent of a greenhouse gas. Just let the methane go straight into the atmosphere. Yeah, it's going to be greenhouse effect on steroids. And then all this oil, it's almost like the natural gas. You just stick a hole in the ground and the oil comes out of the ground. Just set it on fire. It burns. It burns great. I mean, there's black smoke and all that. But hey, we're trying to fight the ice, right? Sacrifices. We're willing to do some sacrifices here. We could just poke holes in the ground to get the methane out, and we can poke holes in the ground to get the oil out, set it on fire, and we dig the coal out with shovels. And we just bring it to the surface and we set it on fire. We already have fire. We know how to use that. We set it on fire and it goes into the atmosphere and we change the atmosphere. And yeah, it'll take centuries. But we're fighting the end of civilization. We don't want to go into another glacial maximum. And the Milankovitch cycles is going to drag us into a glacial maximum. And we don't want that this time. And we screwed up 120,000 years ago. We didn't do the thing. We could have fought this. We chose not to. And we got wiped out. And now we have the tools we have necessary to fight this. And shouldn't we? And that could have been a conversation that our civilization had 20,000 years ago. No, we didn't have that conversation because they didn't know anything about any of this. I don't expect them to. I'm just saying we could have had that conversation and ended up exactly where we are now. Burning fossil fuels, adding CO2 to the atmosphere, and basically violating the dictates of the Milankovitch cycle. In a big way. Because we're not sliding into the next glacial maximum. We are just fucking not doing that. Do you see that happening here? I don't see that happening here. Back in the 70s, when scientists had digital computers, they were calculating cycles, and they were calculating orbital mechanics, and they were very proud of themselves. And they were saying, Time magazine, I remember the cover, Time magazine, Earth is going to go back into another glacial age, another glacial maximum. And you read the article, and it's all about the Milankovitch cycles, because they had kind of verified them using digital computers and like this Vostok ice core. The Vostok ice core, I don't know when that was pulled out of the ground. It's probably a long time ago. Did they even say so when that was pulled? When was the Vostok ice core pulled? They're not really saying in this diagram when that was pulled. You can look it up, right? I could probably ask ChatGPT right now, when was the Vostok? It doesn't matter. It doesn't matter. But they had the ice core, and they had the temperature data, and they had the calculations for the Milankovitch cycles because Mr. Milankovitch did them with a slide rule. And they just put the two together, and they came up with this. And they were like, wow, whew, science is awesome. This is awesome possum. We're going to go into another ice age. Yay. Wow, that's exciting. And everyone else is saying, like, what the fuck? We don't want another ice age. Yeah, but look at the Milankovitch cycles. It's driving your climate. No, it isn't. We are driving our climate. We didn't intend to do that. But if we had known about the Milankovitch cycles, and we had known about the role of CO2 in determining whether you get the cooling or you don't, because of the greenhouse effect, then we might have done what we're doing now on accident. We might have done deliberately pulling up the coal, setting it on fire, letting out the methane, doing the things to increase the greenhouse effect to fight the ice, which is coming because of the Milankovitch cycle. We could have had that deliberate decision to fight it. We did not, because we didn't know. And we still don't know. But what we're doing today is actually, factually, we are eliminating the threat of an ice age. Well, it's all an ice age. It's been an ice age for 5 million years. We are eliminating the risk of another glacial maximum destroying civilization. Yep. There you go. I just made an argument that global heating is a good thing. There you go. I did it. If you're a denialist, that's your argument. Global heating is a good thing, because we are avoiding the next glacial maximum, which would cover half of the Earth's surface, more like 3/4 of the Earth's surface with ice miles thick. We are avoiding that. This is actually called, scientists are calling this a termination event. A termination event. Well, it sounds pretty dire, but it is what it is. We have terminated and exited the ice age that began 5 million years ago. 5 million years ago, conditions were such that we could have an ice age, and it lasted 5 million years. Recently, like in the last 200 years, okay, we created a termination event. A termination event that is now going to hoist us out of the ice age. The planet now has so much greenhouse gases in the atmosphere that the risk of another glacial maximum that buries the Earth in ice for how many? 70,000 years, right? Destroying civilization. That the risk of that happening is zero. We've terminated the ice age. We've now exited a 5 million year ice age. Wow. Okay. That's a thing. That's a thing. It's right here on the chart. You can see it. The pink isn't going down. A little tiny little bit. But that tiny little bit was just us kind of putzing around with the Earth dynamic system. We weren't even trying. In the last 100 years, we've been trying really hard. We've been going at it hammer and tongs, right? And now that pink line, it starts to go up. In fact, maybe at this point, the pink line may already be off the top of the chart. We did that. We're not going into an ice age. We're not going into a glacial maximum. There's not going to be a mile of ice over New York State. There's not going to be a mile of ice over Germany. That's not going to happen. We put an end to that. We terminated. Ussens. We terminated the ice age. 5 million years of fucking around with ice. We terminated it. Wow. Yeah, and in the 70s, Time magazine, right there on the cover, Ice Age coming. Well, sure, Milankovitch cycles. What else are you going to say? Here it is. Read them and weep. We're headed for another ice age. There you go, folks. And then someone else comes along and say, excuse me, I'm a Earth dynamic scientist, and according to Earth dynamics, we're actually increasing CO2 in the atmosphere. Well, these guys doing this math, they didn't know anything about the Earth dynamic system and the greenhouse effect. They didn't know. They didn't have the Vostok core. They didn't know what they were doing. They had the Milankovitch cycles, which you can calculate on a cell phone and a spreadsheet. And they were looking at it. They were saying, oh my God, we're supposed to be going into another ice age. Oh my God, it's going to be ice everywhere. Everyone's going to die. Except greenhouse effect. The temperature of the Earth is influenced by the Milankovitch cycles. We should be going into another glacial maximum, but we ain't. Clearly, look at this shit. Look at this fucking chart. Just look at it with your eyeballs. Are we going into a glacial maximum? Fuck no. Will we ever? Fuck no. It's done. We did it. We did it. We finished it. It's over. Termination event. Wow, we terminated 5 million years. We terminated 5 million years of glacial epochs. Now, must be repeated. The Milankovitch cycle isn't going anywhere. It is Earth mechanics. It's like the gears in a clock that make the hands go around, okay? It is mechanics. It is geared. The gears aren't metal. The gears are gravitational theory, right? And Newton's equations, and the gears are math. The gears are gravity. But they're not, gravity's not going away. Orbitals are not going away. The Theia event already happened 4.5 billion years ago. Can't change that. And we're going to have these Milankovitch cycles, and we can calculate them, and we can predict them, and we can do whatever we want with them, because it's just math. But the temperature of the Earth and the resulting climate isn't math. It's complicated. It's so complicated, it's almost chaotic. And whereas the Milankovitch cycles clearly and obviously from this chart have an influence on temperature, that's not the only thing. And you can see from this chart, from all the places that the pink line does not completely line up with the black line, you can see from this chart all the evidence you need to that it's complicated. Yep. And the Milankovitch cycles are important, but they're not the only answer. And as you can see from this chart, on the far right side, where the pink line is resolutely not doing the thing anymore, that something has changed. And the thing that has changed is us. We're here. We're digging up the coal and setting it on fire. We're digging up the natural gas and the crude oil and setting it on fire. And we do that to the tune of, what is the number again? And I'm sorry, I got confused earlier. That's my bad. The number again, every single day, 100 million barrels of oil every single day. And that's just the oil. There's more for the coal and there's more for the methane. Oil is the big driver. So you can stick with the oil and be essentially correct. 100 million barrels of oil daily, every single day, every fucking day, without fucking fail. Every morning they get up and they go out in the oil fields. Like, hey, boy, what's the numbers? Boys, what's the number today? Just like it was yesterday. 100 million barrels. Right, get out there and make it happen. And what's going to be tomorrow? Even on Sundays. 100 million barrels of oil a day, every day. Make it happen. 100 million barrels daily. And we end up setting it on fire for the most part. So yeah, the pink line doesn't go down. Surprise, surprise. The pink line doesn't go down. Well, okay, that's a good thing. Take the win, right? Take the win. We're not going into an ice age. Phew, big relief. Those guys in the 70s, they were right, of course. They knew the math. The Milankovitch cycles, they were right. They knew exactly what they were talking about. But are we going into an ice age? No. Why? Because it's complicated. Get used to it. In fact, more recent discussion on the same topic, fast forward 50 years, we're now in a glacial termination event. We're in an ice age termination event. It's over. 5 million years of glacial maxima and minima. That was fun. That was interesting. It's over. It's done. We're not doing that anymore. What are we doing? Well, I guess we're warming the planet now. That's going to be interesting. Ice-free, that's going to be a shit show. But hey, there you go. Which would you rather have? Sea level rise or ice sheet advances? Burying your arable land and burying your boreal forests and covering your cities. Which would you rather have? Sea level rise or advancing of the ice sheets? Because you got to have one or the other. All right, well, I guess we're taking sea level rise. Next question. Here you go. Here we go. We're on our way. And I suppose as things continue to get worse and worse, they're going to be saying more and more, it's all the Milankovitch cycles, because they don't want to face the reality that it's fossil fuels. Now, my advocacy is that you stop burning fossil fuels with immediate effect. We've already entered the termination phase of the 5 million year long ice age. We've terminated it. Okay, fine. Maybe that's good enough. We terminated the ice age cycles. Great. The Milankovitch cycles are going to be still there. That's neither here nor there. But do we have to have ice ages? Maybe not. So let's terminate them. We burned the CO2, we dug up the coal, set it on fire, and maybe we're good enough. Maybe we can stop now. If you don't stop now, you're going to get more changes. We have a level of changes right now that is probably enough to terminate 5 million years of glacial advances and retreats. We are now in a termination phase. A little more, and we will absolutely be, without question, in a termination phase. And a little more beyond that, maybe 600-700 parts per million, certainly 1,000 of CO2 in the atmosphere. You can't have ice anywhere on the planet. There you go. What happens after the sea level rises 270 feet? Well, you have different coastlines. All your coastal cities are way, way underwater and completely forgotten. People won't even know they're there. Okay, fine. You've got some buildings that are more than 270 feet high, so maybe the tips of some of the highest buildings will be sticking out of the water. But, seawater is corrosive. They're going to corrode and collapse, and you're not going to have anything. There's not going to be nothing. There's just going to be ruins deep under the water. Hey, people might know that those used to be great cities. And they'll understand some of that. There'll be enough mythology about what came before, but by and large, they won't care, right? They'll just be living on the new coastlines. There will be no ice anywhere on the planet. They won't even remember when there was ice. What's ice? I don't have any ice. Have you seen ice? I can't make ice. I'd love to have some ice. What's ice? I don't even know what ice is, right? They won't understand the question at all. And of course, the weather's going to change a lot. A lot of the weather that we currently understand, even the polar jet streams, the polar gyres, all that stuff is created by ice. And if you don't have ice, what's the weather even going to look like? What are the jet streams going to look like on Earth? Can we even have those kinds of things? I don't know. It's an interesting question, but it's not, it's not that interesting that I'm going to do the work to figure it out. It's just going to come. And we don't even have to ask ourselves, what is the world going to be like without any ice? We're just going to find out. You can ask if you want. You can write fiction. You can, make a movie about it, but it's kind of just wait and see, because that's where we're headed. Wait and see. Now, on the way to an ice-free planet, we're going to be accelerating things a lot. We're now entering a phase. We are now entering a phase of consequences. Everything that we have built, everything that we have known, everything that we've recorded, everything that we've calculated, everything that we've invented, everything that we've innovated, all these things happened during a period of long stability, about 20,000 years of stability. We have now completely overturned that. The stability is gone. So that sucks. We're going to avoid the advancing of the ice and the destruction of our great cities and the destruction of our great nations. We will avoid that. But we have also, maybe it's unavoidable. There you go, right? We have also overturned our long established, long enjoyed period of climactic stability. Trade-offs, right? You don't get buried under miles of ice, but now we got to deal with instability. Okay, fine. If that's the way it's got to be, we'll take it, right? Well, we're going to get it, but we'll take it. And during this period of increasing, you haven't seen anything yet. During this period of increasing instability, remember the Earth is dominated by chaotic elements, butterfly wing, the whole thing is going on now. It's all going to be a shitstorm. As the instability increases, is that right? Instability. I got to be careful here. the instability in the Earth system is increasing. Yes, that is a correct statement. As the instability or the stability decreases, however you want, is the glass half full or half empty? As the instability increases, as it becomes more unstable, then we are going to fight that by throwing even more fossil fuels at it. And going back to my earlier video, Hurricane Helene came deep into the United States, blew those people to rat shit. And they want to be made whole, and they're going to vote for Donald Trump, and he's going to give us all money, and we're going to rebuild our homes, and rebuild our roads, and rebuild the dams, and rebuild the infrastructure. And we're going to be made whole, and MAGA, and wave the flag, and storm the Capitol, and guns everywhere, and, you know, and we're going to spend all this money and burn all these fossil fuels trying to repair these people from a storm. A fucking storm. Not a nuclear war. Nothing of the kind. Just a fucking storm came ashore and blew these people to rat shit. And now we're going to burn fossil fuels and rebuild and do all the things and the roads and the bridges and all this stuff and bring it all back and make it better and make everybody whole and a new car and every child gets a pony. Fossil fuels, yay. And we're just going to make the situation, do I want to say worse? I don't know. Is it okay? Do we like not having ice ages? Are we going to make the situation more that way? I guess we are, because now we have severe weather and it wants to kill us. Oh, and then the sea levels are going to rise because now we're melting ice, because ice is bad, I guess. And so we're going to melt the ice and the sea level is going to rise, and then we have to rebuild all the cities using fossil fuels, I guess, and that's going to aggravate the problem. And then people have to move inland, and they need new cities made with fossil fuels. Oh, no, what are we doing? Why? How can we stop? I guess we can't. And every new storm is going to require 100 million barrels of oil. And every time we have to rebuild a city, it's 100 million barrels of oil. And we're not going to stop burning 100 million barrels of oil daily. Instead, we're going to increase it. And then we're going to be burning 150 million barrels of oil a day because of the floods and the fires and the storms and the hail and the Helenes. And then we're going to be burning 200 million barrels of oil a day because of the refugees and the disruptions and all the chaos and the calamity. And we can't grow food, and we can't build houses fast enough, and the people are moving, and it's bad, and it's getting worse. And then we're having regional wars because of the people on the move and the sea level rising, and people are everywhere, and they don't have houses, and we have to build new houses, and fossil fuels burning, and fossil fuels everywhere and all the time, and 200 million barrels of oil a day, and it becomes 250 million barrels of oil every single fucking day just to fix the stuff that got broke yesterday. Okay. I guess that's what we're doing now. Okay. And meanwhile, the Milankovitch cycle is saying, here we go into another ice age, and we're saying no to ice. No ice anywhere on the planet. Burn the fossil fuels. Heat the planet. Warm the planet. Fuck the Milankovitch cycle. Fuck it. We don't want ice. Ice, be gone. Go away. No ice. And that's what we're doing. That's what we're doing. And going back to this video, it's a good video. You should really watch this. And I was saying to myself, I actually fast forwarded through it. I didn't watch it. I skipped through it enough to see, oh yeah, they're doing a pretty good job here. This is a good video. Can you see what this video is? Here's the title to this video. You should watch this video. You should watch it. How Milankovitch cycles are causing Earth's climate to change. The title is kind of weak. I think the person who wrote the title didn't really actually understand Milankovitch cycles. But let's do the comments, shall we? This should be a shit show. What's going on in the comments? Okay, my comment. It's at the top. Busted. You're busted, Cougar. You made a comment. Well, we'll read this one first, I guess. There always were Milankovitch cycles, as these are orbital mechanics. This guy's right. Well, this guy's me. Of course he's right, according to me. Yet, the Earth has been mostly ice-free for hundreds of millions of years. Also true. The difference, CO2 levels were much higher in the past than they were during the recent ice age, the last 5 million years. Also true. The humans are now pushing CO2 levels back into what they were hundreds of millions of years ago. We're burning fossil fuels. The Earth will again become hotter and ice-free. Sea level will rise 270 feet, and there will be no ice left anywhere on the planet. That's true. That's basically just science. There will be M cycles. It's cutting off my comment, and I'm not getting... All right. Good enough. Next comment, naturally occurring climate change. Now, there's a phrase that I've not heard in a long time. Naturally occurring climate change, fine. Are humans changing the climate in an unnatural way? That's a good question. Is the climate change we're seeing now, meaning the Earth is getting hotter, is there anything unnatural about it? It's human caused, but humans are part of nature. So is there anything unnatural about what we're doing? I don't know. They call it anthropogenic climate change, but does that mean it's unnatural? Good question. I mean, these are definitions, right? This is wordology, narrative warfare, whatever you want to call it. But is there anything unnatural about us digging up fossil fuels and setting them on fire? The fossil fuels are natural. Fire is natural. We're natural. We're changing the climate. They call it anthropogenic climate change. But does that make it unnatural? It's human caused. I don't know. It's a good question. We've decided that we're going to burn the fossil fuels. It's changing the climate. Maybe it's a problem, but is it natural or unnatural? I don't know. Good question. Milankovitch was a super genius. Oh yeah, I'll give the guy credit. Mad props to Mr. Milankovitch. I keep telling everyone that the Earth is still coming down from the last ice age. Coming down from the last ice age. We are in an interglacial. Is that the same way to say the same thing? We are experiencing global warming because it's a natural phenomenon. Oh, well, okay. But are the Milankovitch cycles real or not? Because now he's saying, okay, we're going into another glacial advance, and yet the Earth is warming. We are experiencing global warming because it's a natural phenomenon. But according to the Milankovitch cycles, which you say are real, then we should be going into a glacial advance, not a warming period. So this person isn't even thinking very clearly. It's either one way or the other. I knew there was a theory that supports this. The Milankovitch cycle does not support global heating at this time. Sorry. The reason we're having global heating at this time is because humans are digging up fossil fuels and setting them on fire. According to the Milankovitch cycles, the Earth should be cooling and we should be going into a glacial maximum. According to the Milankovitch cycle. So if you're going to invoke the Milankovitch cycle as why we're having climate change, woo-hoo, it's going in the wrong direction. The planet is heating and the ice is retreating. According to the Milankovitch cycle, which is math, the glacials should be advancing and the ice should be increasing. But it's not. And that's measurable. And the planet is heating, and that's also measurable. And you can't invoke the Milankovitch cycle to explain either one of those. Because the Milankovitch cycle means, at this point in the cycle, which is just math, all those things should be the exact opposite. So this person is a dummy. They're stupid. They don't even understand the topic. I've been saying in this video, according to the Milankovitch cycle, which is orbital mechanics, which is math, we should be going into a glacial maximum. And we're not. And why is that? You can say it's a big mystery, but you can't say you can't say that it's not happening, because it is. And it's really not even a mystery. We've increased the amount of CO2 in the atmosphere to the point that we've altered the greenhouse effect by increasing it. The planet is warming. That's measurable. We can measure that. Instruments, you're going to argue with a thermometer? What the fuck is wrong with you? The planet is warming. The CO2 is increasing in the atmosphere. We can measure that. What the fuck is wrong with you? You're going to argue with that? I mean, either we're measuring this shit or we're not, okay? And actually, we are. And if you're going to say we're doing it wrong, well, you can just be a poopy head. Because we're not doing it wrong. We're doing it. We can measure this shit. We have satellites in space. They can measure all this shit. What is wrong with you? Are you saying that the science is wrong? Well, then you're a poopy head. You've got shit for brains. Whatever. More comments. There's one other major factor that's overlooked. Solar activity. Regardless of what point in a cycle we are in, solar activity variations will play a role. They could, in theory, let's see where he goes with this. If you think about it, the Milankovitch cycles are also all about the sun. No, they're not. They're about the Earth's relationship with the sun, according to orbital mechanics. It's not about the sun at all. And the solar radiation isn't varying. We've had a lot of time to measure solar output without even considering the Milankovitch cycle, because it changes slowly. Math, right? Orbital mechanics changes slowly. And we've been able to monitor the sun's solar output. Instruments, satellites, we got the data. What the fuck is wrong with you? You got shit for brains. What's your problem? And we know that the solar output is not varying much. Certainly not enough to explain the heating of the planet. And, oh, by the way, another thing could be happening, which is the amount of greenhouse gases in the atmosphere. We can measure those too. And if you measure those and you look at the heating of the planet and you notice that the sun's output is not really changing, and and the Milankovitch cycle is actually dragging us into an ice age, then how do you explain the heating of the Earth? Smart guy. You don't. There is no money in Milankovitch cycles. Oh, the conspiracy theories are hot and thick and bubbling on this one. So the reason we're having global heating is because there's money in it. We measure the global heating, you shithead. We measure the increase in the atmospheric component of CO2 in the atmosphere. We measure it with fucking instruments. You think we're making that up because there's money in it, because we can make money in it? No, it's instrumentation. You're stupid. You're a dummy. Can't tax the Milankovitch cycle. Oh, yeah, but we can tax carbon emissions. Should they? I don't know. They're not. Maybe they should. They aren't doing that. I don't know. That's policy. That's politics. That's economics. I don't even give a fuck. Taxing carbon emissions. Yeah, maybe it's a good idea. Maybe it's a dumb idea. Well, we're not doing it, so don't worry about it. Look out. We have some actual science that isn't being made up to generate a payday. Good video. Actually, let's be fair. The Milankovitch cycles isn't science. It's true. It's math. It's math. Oh, and do you know what department the math falls into? Philosophy. Because it's not a science. It just isn't. Math is math. Economics isn't really a science. Economics is math. It's money. It's whatever. And the Milankovitch cycles isn't science. It's mathematics. It doesn't have to be science. Okay? It doesn't need to be. I'm not saying it's wrong. I'm saying it's not science. It doesn't need to be science. It's math. It's computer science, which also isn't a science. Milankovitch cycles can't be used to gain control over every single aspect of human life. These people. Oh my God, these people. What is wrong with them? We're not trying to take control of every single aspect of your human life because the planet is heating. The planet is heating. We don't even know if that's a bad thing yet. Maybe it's bad. Maybe it's good that we don't have so much ice. I don't know. Are we using global heating to control your life? No. Nobody is doing that. Some people think it's a bad idea to heat the planet. You could make a case that it's a good idea to heat the planet. No one's trying to control your life. We're just doing science here. I love it when science proves that climate change isn't a new thing. Okay, first of all, the Milankovitch cycles are not science. They're just predictive mathematics. And climate change isn't a new thing. Oh, that's true. I'll tell you what is a new thing. Anthropogenic climate change. Weans changing the climate. That's a new thing. The Milankovitch cycle is changing the climate is an old thing. There you go. It's been happening for billions of years. The Milankovitch cycles have been going on since the Theia impactor 4.5 billion years ago. True. But the Milankovitch cycles are not always responsible for climate, because that's not the only determining factor. We had Milankovitch cycles the entire time that the Earth was ice-free, which was for millions of years, before the last ice age, which began 5 million years ago. During the rest of the time, the Earth was largely ice-free. And the Milankovitch cycles were still there, because orbital mechanics didn't change. Not since the Theia impactor 4.5 billion years ago. Everything I just said is true. This guy just overlooks the whole thing because he's a dummy. And I don't expect him to be anything but a dummy. This shit is complicated. Global climate is complicated. It's also chaotic. We barely understand the Earth dynamic system. Well, actually, we don't understand the Earth dynamic system at all. We barely understand the human impact on climate. We know we're increasing the greenhouse gases. We know that it increases the temperature of the Earth. We can actually measure both. And is that a bad thing or a good thing? I don't know. It depends on where your values are. 270 feet of sea level rise is going to suck. 270 feet of sea level rise is going to break everything. Actually, 2 feet of sea level rise is going to break everything. You're going to have global wars over 2 feet of sea level rise. It's going to hurt. It's going to be stupid. The poopy heads are going to come out and have global war over 2 feet of sea level rise. It's going to suck. We could have nuclear war over 2 feet of sea level rise. And then it's going to rise another 270 feet on top of that. And it's going to suck, and it's going to be embarrassing, and it's going to be humiliating, and we're going to screw it up like we screw up everything. Oh, we're stupid. And we have nuclear weapons, and we're dumbasses. And we're going to screw it up because we're dumb. It doesn't have to be this way, but it's going to be this way because we're dumb. Fuck. Oh, the comment section. I just lose all hope. The cycles must have a continuous effect on the planet. A continuously varying effect on the planet? What is he trying to say here? It is the time schedule that seemingly most individuals do not comprehend. Okay. I think this person is kind of trying to get at a point here. Oh, they even got a heart from the author of the video. Okay, yes, kinda. But none of this takes into effect Earth dynamics. It's just, yeah, it's worth a heart, but it's like, what have you said? Have you said anything? I don't really know. You missed a whopper. Who missed a whopper? The author of the video? You missed a whopper. There is also a 6,000-year cycle of our solar system passing through the highly charged galactic current sheet. Oh, what? This directly influences solar activity and causes geomagnetic excursions, pole shifts. Oh my God. This is going off the rails. Potentially accompanied with crust uncoupling and sudden tectonic plate shifts. What the actual fuck? Tropical plant material has been discovered under the ice in Antarctica. Not too old either. Okay. Where was this even going? I don't even understand most of this. And how does it have anything to do with humans are digging up fossil fuels, setting them on fire, increasing the greenhouse effect, and heating the earth? Even if everything he said is true, which I doubt. I mean, there's some pretty unhinged shit going on here. Even if it's true, it has nothing to do with humans consuming fossil fuels, which we're doing. Is that a bad thing or good thing? Answer in the comments. Whenever YouTube has the caption box under the video, I think that means this up here, this blue thing is the caption box under the video. Let's go back and see where he's going with that little bit of paranoia. Whenever YouTube has the caption box under the video, it seems the truth is being realized. Okay. I don't know what to make of that. The caption box is trying to point at science, or at least the opposite of misinformation. Yes, we know there's a Milankovitch cycles. What is your point? Yeah, they're pointing in the blue caption box that there's some other information about the Milankovitch cycles. Yeah, because they're true. And you think that gets rid of all our responsibility for heating the planet by burning fossil fuels? No, it doesn't. In fact, the Milankovitch cycle, according to the cycle, which is just math, we should be going into an ice age. The planet is heating. What's your problem? It's complicated. That's your problem. You can't deal with complication. You can only deal with simplified answers to everything. But it's not simplified. It's complicated. In fact, it's somewhat chaotic. And the planet is heating. We're losing the ice. The sea level is going to rise. You better just get ready for that. Okay, that shit's also real. UN notice underneath the video says it all. Never has so much money been wasted on so many massive stipends. Don't know what that means. Stipends. What is he talking about? Whatever. Chimps. This was one of my first college classes, Ice Ages and the Rise of Man, a geology course. Ice Ages and the Rise of Man. Okay, the rise of man, the advance of civilization happened during what we call an interglacial, when the ice was at a minimum. So that was what the course was about. Cause and effect? An interglacial caused the rise of man? Probably. We had an interglacial 125,000 years ago where man could have risen but didn't. Why? Don't know. It's complicated. And we had to know the Milankovitch curve for the final, so I drew it on my forearm. I passed barely. Well done, I guess. What's that got to do with anything? You passed a course that said that man rose during an interglacial. This is incontrovertibly true. It's interesting. It's fascinating. And why did we do it during the current interglacial, which was kind of putsy, compared to the one 120,000 years ago, which was not? That's an even better question. Did they talk about that? Because the current Milankovitch cycle is kind of putsy. We had a much, much more conducive one 125,000 years ago, and we didn't do fuck all. And this time, 20,000 years ago, we just took off and took over the planet. What was the difference? And now we're going into a global cooling according to the Milankovitch cycles, except, oh no, if you actually measure the planet's temperature, it's increasing. I wonder what that's about. Well, it's not about the Milankovitch cycle. It must be about something else. The Earth, the solar system, the galaxy are all cyclical. The Earth, the solar system, the galaxy are all cyclical. Maybe? If you're talking about orbital mechanics, yeah. Glaciers are retreating quickly, yet temperature fluctuates. Temperature of what fluctuates? I'm not sure I understand what you're talking about. The Earth's weather can be a paradox at times, but one thing's for sure, it's always changing and going through cycles. If you mean the seasons, yeah, that's also orbital mechanics, by the way, in the northern hemisphere. One thing's for sure, it's always changing. The Earth's weather. Now, let's be careful here. We're not talking about the weather when we're talking about Milankovitch cycles. We're talking about long-term geological ice ages that began 5 million years ago and have been cyclically advancing and retreating on like a 70,000 year cycle. That has nothing to do with weather. So you've lost me. I'm completely lost. I don't have no idea where this thought process is going, because we're not dealing with weather at all in any of this conversation. Weather doesn't enter into it, period. Just doesn't. Finally, some rational and logic. Finally, some rational and logic. Oh, actually, the Milankovitch cycles have been around for a long time. And in the 70s, we began feeding a lot of data into the computers to really, really calculate the Milankovitch cycles using digital computers. And that has been around since the 70s. So this is nothing new. The Milankovitch cycles, do you think the authors of this video just discovered the Milankovitch cycles? Is the author of this video a gentleman named Milankovitch? I don't think so. They're just talking about the Milankovitch cycles, and they're trying to get people stirred up about global climate change being driven by the Milankovitch cycles, which it is until recently. And the recent thing is important and interesting. And what happened recently is we started digging up fossil fuels, which apparently we were not doing at earlier times in the Milankovitch cycles. We were not digging up fossil fuels and setting them on fire, but now we are. And so now things are different. And that's also rational and logical, because we're doing that. We have data on that. What's the number? 100 million barrels of oil a day, right? Data. We got data. We set fire to this shit. And we know how much CO2 is going into the atmosphere. 40 billion tons of CO2 annually. We know that. Data, numbers. It's all logical. It's been logical all along. Just because you didn't understand it or you didn't know it doesn't mean it's suddenly now a new thing. We've been doing this a long time. We know what the fuck is going on. We know. They've already called it. It's a termination event. We're not going to have any more glacial epochs. The glacial advances are over. It's done. Done. We changed it. Wow. We ended it. We ended 5 million years of glacial advances. Wow. Okay. That's a thing. And that's rational and logical. We know we did it. We did it. We calculated it. We figured it out. The ice can't advance anymore. In fact, the glaciers are retreating and the ice sheets are getting thinner. Okay. That's all measurement. That's all science. It's all satellites and data. We know all these shit. David, you don't accept it. That's your lookout. The main subject that affects climate on Earth is the sun itself. True. If the sun was gone, we would have a different climate. Oh, absolutely. Sunspots, solar flares, solar prominences, and variations in the sun itself determine how much radiation the Earth receives. No, that's not true. No. Solar flares have nothing to do with that. Sunspots have virtually nothing to do with that. Solar prominences and variations, has nothing to do with solar insolation. Nothing. These are short-term events. A sunspot, and they move. They go around the sun. They don't even stay in the same fucking place. And solar prominences last hours, and solar flares last hours, and variations in these things, they last hours. The Earth climate, even the Earth's weather, lasts days and weeks, months, centuries. Solar flares, nothing to do with it. It has nothing to do with it. No. You can say things like that, but it's not true. And when it's obviously not true, these only last hours, days at most. What are you talking about? Oh, fuck. In Winnipeg, Canada, it's minus 40 degrees C in January. Okay, you have cold winters. Thank you for that information. And 35 degrees C in July. You have large swings in temperature in Canada between summer and winter. Nice to know. Every year is called seasonal change. Yes, summer into winter and back again. Orbital mechanics in the Northern Hemisphere. Golf clap. You've learned something in school. Fear-mongering kills you. What? It's cold in the winter and it's warm in the summer? And what? I don't get it. I have a friend from Serbia, Eastern Europe. This is apparently common educational material for them as young students. Oh, so Milankovitch, maybe he was Serbian. That's interesting. I didn't even look it up. It could be Serbian. Great. So they're celebrating their local hero. Good. Yes, absolutely do that. Please do. You should celebrate the people in your country who made significant contributions to our understanding of the Earth system. Yes, please do. Others who have done the same thing, done similar work, of course, Sir Isaac Newton, the Greeks contributed a lot. And we learn more every day from satellites and aerospace and weather balloons and the whole thing. Everyone's contributing, and we appreciate contributions, and you should celebrate your native, people native to your country who have made major contributions to our understanding of the Earth system. Please do. Does that mean that you people know more about the Earth dynamic system than the rest of us? No. Does that mean you solved the climate problem in your 5th grade? No. It's complicated. The work done by Milankovitch and the work that you can do on a cell phone in a spreadsheet, it doesn't tell you the whole story of what's happening on Earth. It's complicated. You see this little wiggly pink line at the far right of this chart? Yeah, you don't understand what's happening. Get used to the fact that you don't understand. Me again. I have noticed that our summers start later in the spring. Summer starts later in the spring. Actually, it's exactly the opposite. So what you're noticing doesn't count for fuck all. And go further into the fall than when I was a kid. The seasons are the same length. They are just shifted a month or so. Whatever. No one cares. Who cares what you've noticed in your particular neck of the woods? Your observations are completely irrelevant, and probably every year they change. But on the whole, on the average, with time, the Earth is warming and the CO2 increases. The CO2 levels in the atmosphere are increasing, therefore enhancing the greenhouse effect, which does a lot to explain why the Earth is getting warmer. End of discussion. Who can dislike this video? This is absolutely well-explained video about climate changes. No, it has nothing to do with climate change. In fact, I don't think they even get into it. I kind of skipped through it a little bit, but I don't think they even addressed climate change because they know it's sort of toxic. They just talk about Milankovitch cycles. That's all they talk about. Milankovitch cycles are not the same thing as climate change anymore. And maybe before humans started burning fossil fuels, you could make a claim like that. But these days, no. And if you don't agree, there it is. Goes up, the temperature goes up, goes down, goes up, goes down, goes up, goes down, goes up. It goes up and it stays up. Oh, and more recently, it goes up even more. But look what the Milankovitch cycle is doing. It's going down. We should be going into a cooling trend and a glacial maximum. We're not. I wonder why. And if you look at the data, we can't. The Earth is, the atmospheric component of CO2 is increasing the greenhouse effect, and therefore warming the Earth, and the Earth is getting warmer. End of discussion. It's not happening. Yeah, they think they are stupid, I get. Okay, well, whatever. Our Earth is an amazing thing. The Milankovitch cycles are actually not about the Earth. I mean, I'm not disagreeing. I'm just pointing out that the Milankovitch cycles are about orbital mechanics. It's the relationship between the Earth and the Moon and the Sun. It's a three-body problem. Wait, we can't blame the fossil fuels anymore? Oh, absolutely you can blame the fossil fuels. For the end of the Ice Age, for the termination of the Ice Age event, which was started 5 million years ago, you can absolutely blame fossil fuels for that. Foursquare, ironclad. Blame fossil fuel consumption for that. But is it a bad thing? I don't know. You could think that ending the Ice Age is a good thing. Now, you're going to get 270 feet of sea level rise. Oh, okay. Well, that's a problem, but it's a different kind of problem. Your civilization was going to be destroyed by an ice age and glacial advance. That's bad. And this way, your civilization is destroyed by sea level rise. Also bad. Is one worse than the other? I don't know. Maybe an ice-free planet is generally a good thing. I guess we're going to find out. I will contend that you can't have 8,000 million people, 8 billion people on this planet with 270 feet of sea level rise and 10 degrees C above pre-industrial baseline temperature. I don't think you can have that many people. I think you can have maybe 8 million people on this planet with those conditions. And that's 1/10 of the current Earth population. So, yeah. We are still in Ice Age. It started around 2.7 million years ago. Yes, that's true. However, scientists now say we have entered a termination phase. Let's see if he says that. And there have been between 30 and 50 cycles. Okay. But during that period, we are presently in the Holocene interglacial period. We are. The previous one was about 125,000 years ago. See, he's saying the same thing I was just saying. I'm not a dummy. You can read the fucking chart. If you didn't know these things and I didn't say them, you could actually just read the chart and figure this all out on your own. Often called the Eemian interglacial for about the first half of the present ice age. I should highlight this, you know what I'm reading. Ooh, there's read more. Okay. Ooh, this is long. Okay, let's see what's happening here. For about the first half of the present ice age, the cycles were more or less 41,000 years long. Yeah, then they got longer and they got deeper. And that they do talk about that in the video, which is kind of cool. So this is sort of a summary of what the video actually talks about. Well, that's kind of nice. If we stop burning fossilized, sequestered carbon, the planet's biology and geology will eventually lower the CO2 level in the atmosphere. And when the next Milankovitch cycle is at a low, which is kind of entering a low temperature in the summers, okay, snow will begin to accumulate starting on the highlands of Baffin Islands and will spread southward. Yeah, that's the glacial advance during a Milankovitch minimum. That's what it's been like for the entirety of the time we've been here until recently. If we have used up all of the sequestered carbon, we will not have anything to hold off the next interglacial period, and it is likely that the Great Plow, which is the continental ice sheet, will plow all our human artifacts southward. Okay, I have to read this again. Something feels a little off with this sentence. If we have used up all the sequestered carbon, we will not have anything to hold off the next glacial period. Okay, this person is a little confused. The amount of carbon we've already burned is enough to terminate the 5 million year long ice age. We are in a termination event. We have hit a termination event, is current science. And there's maybe some disagreement about whether it's really a termination event. But we know that the glaciers are contracting, not growing. We know that the ice in the at the North Pole is thinning and retreating. And we know that floating ice sheets all around the North and South Pole are disintegrating and being lost. So with just the changes we've made to the Earth dynamic system, meaning 400 some odd parts per million of CO2 in the atmosphere and the commensurate warming to the atmosphere, we have already basically terminated a 5 million year long ice age. We've done that. We did that. We probably started doing that 5,000 years ago by burning forests and draining swamplands and putting all that carbon in the atmosphere. We've been stabilizing the climate for actually a long time. And just recently, like the last 100 years, we went completely apeshit doing that same thing. We discovered fossil fuels 300 years ago. And in the last 100 years, really the last 50, we've just gone completely overboard burning fossil fuels. And we love our modernity, right? My internet and my computer and my microphone and my coffee from Ecuador and all this other kind of stuff. We love this. More, please. But we're burning fossil fuels, so there you go. So this sentence is kind of weird. I don't know where this is headed. The rest of this, up until that point, looks like a good summary of the video. Watch the video. The video's good. I'm not complaining about the video. I have nothing bad to say about the video. Much. The video is a good video. If you want to learn about the Milankovitch cycles, watch the video. If you want to learn about climate change, that won't help you. Because it's not about climate change. We are changing the climate by burning fossil fuels. Well, actually what we're doing is we're heating the planet. We're heating the planet, which will change the climate in turn. Okay, you're going to lose all the ice. You're going to get 270 feet of sea level rise. Yes, climate is changing, of course. But it's global heating caused by CO2 emissions into the atmosphere, which come from burning fossil fuels. Is that a good thing? Is that a bad thing? You tell me. You go in the comments and you tell me which you prefer. Do you prefer another ice age, advancing ice sheets that, yes, you plow our artifacts to the equator? That sounds bad. Or do you rather have 270 feet of sea level rise? Good question. Good question. Could I do a video on that? I mean, it would just be my opinion, right? Like, which do I prefer? Yeah, I can see a downside. I can definitely see a downside, but the things we're doing now are also pretty fucked up. So we have to kind of stop doing what we're doing regardless. I mean, the impact we're having on the Earth is not going to be able to feed us. So we're kind of fucking up right now. And could we stop fucking up? I guarantee you another glacial maximum would stop us from fucking up. Absolutely, 4 square. Guaranteed that we would stop fucking up. Would 270 feet of sea level rise and a complete change in the Earth dynamic system accomplish the same thing? Wow. Yeah, that's an interesting question. I mean, it's all conjecture, of course. It's all science fiction-y stuff. We know what an ice age would do. We know what a glacial advance would do. It would just plow us under. 2 miles of ice over New York City. Well, that's the end of that, right? They're not going to be doing anything. They're not going to be burning fossil fuels. They're not going to be having libraries. They're not going to be doing anything. That would suck. But how about 270 feet of sea level rise? Oh, yeah, okay. Actually, New York also goes underwater. So, same impact. I don't know. Worth thinking about. It's like, pick your poison, right? Yeah. What else can I do with this comment? In the meantime, we have put off and even possibly stopped the glacial period. Yes, that Milankovitch cycles predicted should be on the way. Yes. He finally got back to the point. Good. If it is enough, we could keep the next glacial period at bay. Yes. Until we enter the next interglacial warm period. Okay, that's a little bit unhinged. The current interglacial warm period never ends and maybe continues forever. So there's going to be, you can't say that we end the glacial period and then go and say, oh, and we're going to have another interglacial warm period. If you end the glacial ice ages, then the whole interglacial warming period is just, it's not a thing because you don't have glaciers, and therefore you can't have an interglacial. You see, I'm not being mean here. I'm just saying that if you end ice, then you can't have glaciers, and if you can't have glaciers, you can't have interglacials. And you can't have interglacial warming periods. So this is the person kind of understands, but they're not continuing the thought process far enough out. Unlikely though. We may drive ourselves into extinction before this happens. Okay, this comment is actually pretty good. It's a little bit. This person should watch this video that I just made. What I want to say is that this was 3 weeks ago. I could actually make a comment against this comment and point to this video. I could do that. Should I do that? Hi, welcome to my video. I liked your comment, and that's why I linked my video to a reply to your comment. I hope you enjoy my input. I didn't mean to be mean. Your comment is actually pretty good, but I don't think you thought this through all the way. We're going to get 270 feet of sea level rise, and that's going to end all glacial periods. The Milankovitch cycles will still be there, which I think you don't. What I think you don't understand in your comment is that the Milankovitch cycles were always there. Always there. The glaciers only happen when the CO2 levels in the atmosphere are low enough to allow for ice formation. We have elevated the CO2 levels enough and will continue to do so that ice on Earth becomes impractical. Therefore, you cannot have ice ages. You see? It's kind of a definition thing. If you can't have ice, then you can't have ice ages. Now, you can have the Milankovitch cycles because they're orbital mechanics. They don't go away. Orbital mechanics, this Earth still goes around the sun. The sun is still there. Nothing really changes. But you can't have ice ages because if the CO2 levels are too high, you can't have ice. It's just a definition thing. And therefore, you can't have interglacials and you can't have warming periods, and all that stuff is done. All that is done because you can't have ice ages, because you can't have ice. You see, it's just definitional. It's like it's by definition you can't have an interglacial warming because you can't have a cooling. You see? But it's a good comment. Now, this other part, we may drive ourselves into extinction before that happens. Well, okay, we're not going to have another interglacial. We may drive ourselves to extinction. Now, I've done other videos that comment on this. Oh, and if you're this person, random name, you may want to watch some of my other videos where I talk about human extinction. Human extinction is really not a thing. Even a 99.9% 9% die-off of humans, which is like, that's a lot, right? 99.9, that's almost 100%. 100% is extinction. That's kind of the definition of extinction. 100% of you are dead, you're gone. You don't exist anymore. And a 99.9% die-off of humans, wow, that might as well be 100%. But it's not. And it still leaves 8 million people. 8 million people is not zero. It's not even close. And we are so influential and we are so smart that 8 million of us left is still like a major civilizational thing. We could have flying cars. We have, Jetsons. We could go to Mars with 8 million people. We could still be doing exactly what we're doing now with 8 million people. And that's not extinction. No, we're not going extinct. Well, I can't rule it out. But no, I don't think so. I don't think humans ever go extinct. Now, of course, a 99.9% die-off is a stupid thing to want to do. And we're going to get that anyway. I'm going to do a reply. I'm going to do this. I'm going to do this live on stream. Great comment. I did a reaction video to this video and I saw your comment and talked about it rather a lot. If you want to. Is this even fair? If you want to see my video on this topic and your comment, go here. Now, of course, someone can come along and now I have to find my video. Can I do this? Can I do this? Here's my live streaming, and I am live streaming, and I don't. Where is my? Can I do this? Can I? This is dangerous. I hope I don't destroy the stream. If I destroyed the stream, thank you for watching. Let's see if I can do this. Edit. Can I get a URL yet? Can I get a URL to this video? I don't see it. No, I can't get a URL to this video. I guess I can't get the URL until it's done. Is that how this works? See, these are not viable URLs. Wait, what is this? Add stream marker. Create highlight video. Okay, I don't know what I'm doing here. Wait, what is this? Share. Ooh. This is the magic. Share. If I wanted to share, this is the, you see, copy. Ooh, look at what I'm doing. This is like major. I am being so on top of things here. And I'll even put it in the title because I know what the title is. I think I do. Live streaming. Savage Sciences. Okay, here we are. I don't know why I'm doing this. This is dumb, right? This is so dumb. I'm being so silly right now. Okay. All right. Reply. Ha ha. Ha ha ha. I'm so funny. I'm so clever. I'm so full of shit. Great comment. I did a reaction video to this video. I saw your comment and talked about it rather a lot. If you want to see my video on this topic and your comment, go here. I'm sorry. I am so sorry that I did that. And you had to watch. I'm so sorry. I should edit this part out of the video, but I don't edit my videos. You just have to put up with me being silly. Okay. All right. Of course, YouTube puts up a statement since this video concerns climate change. No, it doesn't. It doesn't. And does the blue box even mention climate change? Human activities have been the main driver of climate change, primarily due to the burning. Okay, yeah. All right, so they do. In fairness, they do mention climate change in the blue box. Of course, YouTube puts up a statement since this video concerns climate change. It doesn't, but there's a tie-in, okay? Human activities have been the main driver of climate change in the current interglacial, okay? Primarily due to the burning of fossil fuels like coal, oil, and natural gas. True. That's all true. That's all science. That drives policy. No, not really. Well, I mean, might drive policy. Do you not want climate change? Do you not want global heating? Maybe there's some policy you have to deal with. I don't know. I don't know about driving policy. It's a decision we have to make. That's all. Which can be hugely counter-effective if it is not actually true. Global heating is true. Fossil fuel consumption is true. Enhancements to the greenhouse effect are true. It is warming the planet. All that's true. Is it a good thing or a bad thing? I mean, that's your bifurcation. That's your decision point. Is it a good thing or a bad thing? If you think that heating the planet is a good thing, full stop. Party on, all right? If you think that heating the climate kind of stupid, then you may want some policies. I mean, that's it. That's the whole thing. That's the whole decision point. That's the whole fork in the road. That's it. That's all of it. Not that human activity does not have an impact, but that it is vastly not the main driver. Oh, it is totally the main driver. And so you can be in denial. That's okay. And if you're going to be in denial, then what you're saying is party on. We're going to go forward. We're heating the planet. Fuck it. It's a good thing. And if it's not a good thing, it doesn't even matter. It's fake. It's a hoax. Party on. Okay, that's an answer. Party on. Keep going. More of the same. Business as usual. That is one of the forks in the road. And the other fork in the road is, oh my God, this is stupid. We suck. We have to stop doing this. Okay, that's a decision point. And the nations of the world have to decide if they're going to go one way or the other. That's it. It's just policy. It's a decision point. Decide. But it's true. It is true that you have that decision to make. Make it one way or the other. And the default, of course, no decision is party on. That's a decision too. And if you say it's a hoax, it's all made up, it's all a conspiracy, party on. You just made a decision. Global warming all depends on context. No, global warming is a measurement. Global warming is a measurement. We can measure it from space by satellites. It's a measurement. The globe is heating. It's a measurement. It's not a context. It's not an opinion. It's not a theory. It's instrumental. It's a measurement. What else can I say? There's nothing more to say. You can not like it, but you can't say it isn't true, because it's a measurement. Got it? You can say you don't like it. You can say we should stop measuring. You can say all those things, but you can't change the fact that it's true. Over the last 1,000,000 years, how warm is warm and how cold is cold? Okay, fine. Also, with regard to the rate of change, how fast is fast and how slow is slow? Huh? Where is this going? It's all relative. These people give me a headache. Just because the temperature is different today than it was 20 years ago doesn't mean anything. It might mean something to somebody, okay? What if it's 10 degrees C hotter? That's about 25 degrees Fahrenheit. Would that matter? Would you care? There are some places on Earth getting so hot that they're going to become uninhabitable, including major cities in the United States of America. Phoenix, Arizona, I'm looking at you. Oh, and we just had Hurricane Helene come through and blow parts of western North Carolina and the surround to absolute rat shit. They probably have some thoughts about that, okay? Oh, we have hurricanes all the time. Not like that one, you don't. It's a measurement. It's a thing. It's a fact. It wasn't caused by global heating. The fuck it wasn't. It's a heat engine. Hurricanes are heat engines. Heat engines. Emphasis on the word heat. Why do I do this? Why am I continuing to even do this? This is really well made and thoughtful video. I'm not sure it's thoughtful. It's just talking about, Milankovitch cycles, orbital mechanics. It's not thoughtful. It's a documentary, right? I even enjoyed the engagement activity at the end. Whatever that was, I wasn't paying much attention. Yes, these cycles are vastly more impactful than the current carbon dioxide panic. Well, yes, I suppose. Let's go back to our chart. So these pink line, it goes up and down and up and down. It's in confirmation with the Milankovitch cycles, up and down and up and down and up and down until the very end. Okay, that's fine. But I'll tell you that there have been times in this planet's recent history, like the last 300 million years, when the Milankovitch cycles were going up and down and up and down and up and down, and there was no ice anywhere on the planet. None, anywhere. No ice. Milankovitch cycles, orbital mechanics, up and down, up and down, up and down, up and down, up and down. It's clockwork, right? It's gears. It's mathematics. Up and down, up and down. No ice. So it's not that impactful. Remember, if the CO2 levels are low enough, then the Milankovitch cycles can influence the temperature of the Earth. That's true. But only if the CO2 levels are low enough. You see, cause and effect. And if the CO2 levels get high enough, then the influence by the Milankovitch cycles doesn't count much. There you go. Cause and effect. I gotta stop. I'm kind of enjoying this. And I think this is an important exercise. I think that as people start to become more and more aware of what's really happening in the Earth dynamic system, they're going to start looking at videos like this one and studying the Milankovitch cycles, and then they're going to go into the comments and they're going to get fucking confused, okay? We have to be very clear on what's happening here. The Milankovitch cycles are real. They are orbital mechanics. It's like the tick-tock of a clock. It is predictable. You can measure it, and you can calculate it. And Newton had all the tools, calculus, to calculate the Milankovitch cycles. He didn't know they were there, but he didn't have to know. He just had the tools. We came along, and we learned a little more, and we took his tools, and we calculated the Milankovitch cycles. One and done, all right? They're real. They have an influence. But the Earth dynamic system is complicated, and climate is complicated, and changes in lots of parameters, including the amount of atmospheric loading of CO2, have a huge and sometimes outsized influence on whether the planet has ice or not. And if the planet has no ice, then the sea level is 270 feet higher. And the Milankovitch cycles were always there, and the sea level was 270 feet higher than it is today, because there was no ice. Everything I just said is true. Everything I just said is true. And when you come to a video like the one I'm making now, and when you go to videos like the one I have right here, that I should link it in my own description. I will do that. I should have did it at the beginning. When you come to these videos and you start going through the information, you have to understand that there is not one simple thing. A few years ago, before the people started learning about the Milankovitch cycles, they were saying, oh, it's all solar output. If the world gets hotter, it must be because the sun is getting brighter. But the sun isn't. We got data on that. Go look at the data. It's not changing. But sunspots change. But that's not sufficient to explain the data. The sunspots go up and down and up and down and up and down. The heating of the Earth goes up. Where's the sunspots in all that? They're nowhere. And if they're making an influence, it's lost. It's just lost in the noise. And there is no simple explanation. If there was a simple explanation, I would tell you. Scientists would tell you. It would be all over the news. Hey, there's a simple explanation. And it's this. It's A and it's B and leads to C. And it's simple as that. Just 3 points on a line and we have our answer. There's nothing complicated about it. But it isn't simple. If it was, we would tell you. And what we're telling you instead is, oh man, this shit's complicated. And we're not saying it's complicated because we want more grant money. We're saying it's complicated because we can't figure it out. It's too complicated. It's dominated by chaotic elements, and there's so many moving gears, and we think the Earth is getting hotter because we can measure that. We're not really sure why, but the CO2 is going up in the atmosphere, and that enhances the greenhouse effect. So Earth getting warmer, greenhouse effect being enhanced, CO2 being released into the atmosphere, right? 40 billion tons a year of CO2 being released in the atmosphere. God, that's got to have an impact, right? And we look at the temperature increasing, we look at the CO2 releases, and we look at the Milankovitch cycles, and we put all this together, and we write papers, and we analyze our own papers, we talk about it ourselves, and we're like, yeah, humans must be doing this. There can't be any other answer. If there's another answer, we'll let you know. Well, right now we got nothing. We got nothing. It's humans. We're doing this. And then we can ask ourselves, should we stop doing this? And then that gets into policy. But the scientists aren't writing the policy. They're just measuring the data. And so at some point, these videos are going to be helping to determine policy. But the fork in the road is, do we stop altering the Earth dynamic system? Do we fear a future from one decision or another? Which is the more fearful decision? And maybe anything we do, maybe burning fossil fuels is really bad. And then maybe not burning fossil fuels is also really bad. And so, but you got to do one or the other, because it's a fork in the road, and there's not 3 or 4 ways. There's 2. Either burn the fossil fuels or stop burning the fossil fuels. That's it. Do it or don't do it. And so what are you going to do? And that's policy. That's it. And of course, the default decision, party on. Just go forward, doing what you're doing today and do it forever. Except you won't do it forever, because something will change. Something will break. All right, I'm done with this. This was fun. This was a good video. I didn't have any problems with the video. How the Milankovitch orbital variation shape Earth's climate. Yep. Yeah, there's some of that. And the follow-on video would be, I guess, mine. How human exploitation of fossil fuels has basically made the Milankovitch cycles irrelevant. Because for most of their history, they were always there. They just didn't have much to say about the Earth's climate. The Earth was ice-free, as it's going to be soon, seems to me. And there you go. You can have, 2 things can be true. The Milankovitch cycles can be important, and then the Milankovitch cycles can be unimportant. Those can both be true. And, it just depends on other factors. Stopping